So let's find the resultants of these vectors. So we have, so I can do it direct and I can set up a table for it. So let me set up a table so you can actually understand better. So we have force, angle, horizontal components, vertical components. So the horizontal component x, vertical components y. So what are the forces you have here? So I have force of 4 Newton, 6 Newton and 8 Newton. So 4 Newton, 6 Newton and 8 Newton. So remember I said anywhere the angle lies is cos. So that means in this case this vertical will be cos, horizontal will be sine. So but you can actually change the angle to the horizontal also. If here is 16, here will be 30 degree because sum of angle here is 90 degree. If here is 30, then here will be 60 because sum of angle here is also 90 degree. So I'm using the horizontal angle. So your horizontal can be cos and vertical can be sine. It's not wrong if you still use this 60, but then vertical will be cos, horizontal will be sine. But because of what I've been doing so far, so I'm changing it to horizontal, so we still have the same pattern. So now for 4 Newton force, the angle is 30 degree. Remember, it's not wrong using 60, but then horizontal is sine, vertical is cos. But since I'm using the horizontal angle now, horizontal is cos, vertical is sine. So for 4 Newton, the angle is 30 degree. For 6 Newton is on the vertical, so the angle is 90 degree. So I've said it that any force that falls on vertical, that is at this right angle, the angle is 90 degree. Anyone that falls here, the angle is 0 degree. Can go and watch the previous examples. So now I have 30. For 6 Newton, the angle is 90 degree. So for 8 Newton, the angle is 60 degree. So this one, yeah. So now for horizontal components, so you need the sign convention. So let me show it. Remember the sign here, this is plus, plus, minus, just like if you have cardinal points. So the any number you write here is positive, positive, negative, negative. So we take all this as our direction. So now I'll consider that in my workings. So this will becomes for horizontal, so that will be for 4 Newton. If you resolve to horizontal is plus, as in just drag it this way, the way you see the arrow to the horizontal, that is plus. So that is plus 4 cos 30 degree. Drag it to the vertical, that is both horizontal and vertical, is also plus. So that is plus 4 sine 30 degree. So for 6 Newton is in vertical already and the sign is plus. So that will be plus for vertical 6 sine 90. For horizontal, if you drag to the horizontal, is plus 6 cos 90. So if you go anti-clockwise, this is 6. If you come this way back to the horizontal this way, that is clockwise, and if you go anti-clockwise this way, you still get the same results. The only one that will be valid here is this 6 sin 90, because cos 90 is 0, so sin 90 will be 1. So if you like, you go anti-clockwise. So instead of saying plus, that is if you go horizontally this way, so instead of saying plus here for horizontal, you can still go that way and say minus. So if you go clockwise or anti-clockwise, you will get the same answer. But if you are going clockwise, do clockwise throughout. If you are going anti-clockwise, do anti-clockwise throughout. So that is it. So now we have minus 6 cos 90 plus 6 sin 90. Anyway, so for 8 Newton, so that is go this way, minus horizontal, that is minus 8 cos 60, then vertical backward plus 8 sin 60 degree. So now add everything together. Yeah, also add everything together. Yeah. So now that will be 4 cos 30 minus 6 cos 90 minus 8 cos 60. So that is minus 0.5 minus 0.5359. So that is the horizontal direction. So it remain this vertical. Add down also. So add all the forces. So we have 4 sine 30 plus 6 sine 90 plus 8 sine 60. So that is 14.928 Newton. So that is our result addition. So that is the horizontal components and some of the vertical components. So, and without table, you can actually solve this too. So I've done an example like that. So that is, we resolve all the horizontal at once. Also, you resolve all the vertical at once. We've done that before. I can still do that in this question. So I have this two now. So my horizontal components, as in sum of, that is summation fs, sum of all the forces in horizontal, that is minus 0.5359 Newton, and summation fy 14.928 Newton, like that. So now from here we can now find our resultant. So we have resolved everything now into horizontal and vertical. So if you don't want to use table, so using the same diagram, let me show that also, so anyone is allowed. If you don't want to use table, you just go straight by saying summation fs, that is sum of all the forces in horizontal direction. Now 4, resolve it to the horizontal, that is plus 4 cos 30 if you are using 30, but if you are using 60, then vertical is sine, cos, horizontal is sine if you are using 60. that you have in the question. But since I'm using 30, I'm using the horizontal, so horizontal is cos. So that will be plus 4 cos 30. Which force do you have in horizontal? This is vertical, so I'm doing only horizontal. So horizontal again, minus 8 cos 16. So this is our summation of all the horizontal forces. So 4 cos 13 minus 8 cos 16. So you still get the same thing as minus 0.5359. So it's still the same as this. You see now. So instead of using table, you can actually go this way. You will still get this summation fs direct. And if it is the previous angles you are using, so I'm only doing it in different ways so you know it's not one direction. If it is this previous angles you are using, then where the angle lie is cos, that means vertical is cos, horizontal is sine. Then this will be 4 sine 60. Then that is I'm taking 60 now. So if I take 60, my horizontal is now sine, vertical is cos. So then minus 8 sine 30. So if you use this, you still get the same thing. So press your calculator. 4 sine 60 minus 8 sine 30. So you still get minus 0.5359. So it depends on the angle you choose. So I choose any angle here, but remember anywhere the angle lies is cos. So that is summation fs. So if you are doing summation fy, so if I'm using the horizontal angle here, then my horizontal is cos. But if I'm using the vertical angle here, then the vertical is cos. Take note. So now using horizontal now for vertical. So resolve this 4 to vertical. So that will be plus 4 sine. No, I'm using horizontal angle. So if I'm using horizontal, this place is cos, vertical is sine. Now I'm doing vertical. So plus 4 sine 30 plus 8 sine 60, then plus 6 because this 6 is vertical already. So just add plus 6 because the sign there is plus. So add everything together. So this is without table. So 4 sine 30 plus 8 sine 60 plus 6, that is 14.928. So the same as previous. So you can actually solve without that table. So but that table is just for you to see what we are doing clearly. Okay, so we have known our summation of fs and fy. So now in your cardinal point, remember this is plus plus minus minus. So negative of x, that is summation fs, that means towards the x direction, but the negative. So that means your first arrow will face here, as in this place is now 0.5359. You see it's facing negative direction. Then y is positive. So if y is positive, remember this is y axis, this is x axis. So that means the other one is facing up. That is 14.928. It's plus. So that means your diagram will be like this. So that is what we are doing. So now the resolved diagram now for vertical is like this. That is plus. That is 14.928 Newton. Then horizontal 0.5359, not drawn to scale. So now resultants will pass through their middle. So this is our resultant. Remember this is 90. So now for resultant of two vectors which act at 90 degree to each other, so we have summation fs square plus summation fy square. So our resultant is equals to square root of 0.5359 square plus 14.928 square. So r is equals to square root of, so add find the square, 0.5359 square, that is 0.2871, plus then this one square also 14.2 14.928 square, so that is 222.85. So now add everything together, as in this two. Everything is just calculator work now. So r is equals to 0.2871 plus 222.85, so that is 223.14. So your r now, square root of 223.14, that is 14.9 Newton. So that is our resultant, 14.9. So your resultant is 14.9 Newton. Now it remains the direction. So this 14.9 is your magnitude. So this is for I now. So we have done I. So I, your magnitude is 14.9. So now let's say the direction. So for direction of the resultant, so if I choose here to be my direction of resultant to the horizontal, so that is alpha to the horizontal, so that means this will become tan alpha is equals to, that is opposite over adjacent, or generally now, so that I will not be using tricks. So alpha is arctan y over x. Remember, if I project this force, if I project it here, I will have something like this. This is opposite over adjacent, that is tan. That means 14.928 divided by this, so that is y over s. So and that is now arctan. So alpha is equals to arctan 14.928 divided by 0.5359. So alpha is equals to, divide arctan 14.928 divided by 0.5359. So that will be 27.86. So alpha is arctan 27.86. So that is 87.94 degree. So this alpha now is 87.94 degree. 87.94. So that is your alpha. That is the angle which the resultants make with the horizontal. That is alpha. But the direction of, you can, if you take this as answer, then that will be like the angle which the resultants make with the horizontal. So that is your alpha. But the direction of the resultant force will be, so let's assume I complete this my cardinal points. Let us assume I complete it this way, like this. So the direction of my resultant force, the true direction of my resultant force is, let me find this place first. Total angle here is 90. If here is 87.94, then what is this small portion? So So that will be 90 minus 87.94. That is 2.06 degree. So if we know that place too, so that will be 2.06 degree. So your true direction of this resultant, the true direction is, if you go from north, as in from here, that is if you go clockwise, the direction of your resultant is like adding the angle here, that is 90 plus 90 plus 90, 270. So 270 plus 87.94, 270 plus 87 points, so that is 357.94. So if you go, that will be the true direction. But for here, it is the direction which the resultant make with the horizontal, the angle which the resultant make with the horizontal, that is this. So you can also represent this portion as, remember this is north, south, east and west. So this place now, if you have cardinal like this place is north, theta degree is south, north theta degree west. So here will be north, theta degree north of west. So it depends on your direction. So I can say my direction of resultant force is 87.94 degree north of west, or north 2.06 degree west, because this is north west. So anyhow, I can leave my direction this way. So that is it.